Hi, dear professor. I hope you are doing well. I am Mohammad Sharifullah, a PhD student in Department of Mathematics. In this video, I am going to explain my program about the naive multi-threaded prime number generating using pre-threads in language C. The goal of this assignment is to launch multiple threads. Each thread runs in independent brute force algorithm to find a random prime number. So the main objective of this project is as follows, like initiate a customizable number, instruct each thread to create random integers and evaluate their primality autonomously, collect and print all outcomes after the completion of the threads. In implementation process, three programmable macros manage the runtime parameters. Number one, num threads, maximum tries, and max bell. So now I will going to explain the code structure, how threads are created and joined, describe the logic for generating and testing primes, and finally show the output. Then I give some concluding remarks. This is the code. So in this code, the first these are based on like include headers. The first one and the first and second one is for input, output, and general utilities, and third one is for a POSIX thread library, and fourth one like is for it gives access to squared function, which I used it for checking the prime numbers. And this one is for portable integer types. And the final last one, time.s, is used to seed the random number generator with the current system time. Also, these three lines, um, it's like constant and a function of prototypes. The first one is shows that control how many threads are created. For this assignment, I use 30. If I can use it's 100, then it will works accordingly. And the second one, how many times I will try, like how many random numbers each thread will test before giving up. And the third one is for define the upper bound for random numbers. Each thread will generate random numbers between 0 and this maximum, and then test for primality. And the next one is the main function overview. Um, I first declare an array, like um, declare an array of thread identifiers and another array to store results from each thread. Then I seed the random number generator using um, srand time null. This ensures that each run produces a different set of random numbers. Then the this one is for thread creation. Here I create the threads in a loop using pthread create. Um, each thread executes the find prime, this one, find prime function, and the um, thread ID I is passed as an argument. This means all 30 threads start running in parallel, is trying to find like a random prime number independently. Then this portion is for thread joining and output. After launching the thread, the main thread waits for all them to complete using pre-thread join. This one, pre-thread join. Each thread returns um, either a prime number or zero if it could not find any prime within its maximum tries. The results are stored in the results here, um, array and printed. This section also demonstrates how to collect return values from thread in programming language C. Then this portion is like thread function find prime. This is main logic executed by the each thread. The thread repeatedly generates a random unsigned long integer rand using the rand and check if it's prime. If a prime number is found, the thread exits immediately and return that number using pthread exit, this one. Otherwise, after maximum number of tries attempts, it exits returning 0 to indicate a failure. Then this portion is like prime checking function. The is prime is prime function performs um, a simple brute force primality test. It eliminates even numbers first, then iteratively check for divisibility up to the square root of the number. And this one, if no divisors are found, the number is declared prime. This algorithm is not optimized, but it's intentionally made to create um, heavy computation for threads. Now I will run my code in SPC using the SPC. Here there is my code which I described early a few moments ago. This is my code. Then I need to execute it. Then I need to run it. In this code, here I use the number of threads like 100 times. If I say it is like 30, then it gives me just 30 times. Now it just gives me, sorry, now it gives me just 0 to 20, that means uh, 30. And I already described if it's a prime number, then it show the number. If it's not prime, no prime. So finally, finally, this simple This experiment demonstrates how to create and manage multiple threads using POSIX threads, POSIX-P threads. Each thread performs independent computation, illustrating data parallelism and CPU-bound concurrency. Um, and that's all of my explanation.